So, Pythagoras and Cubes, we have a cube, and remember the property of a cube is that all the faces are congruent and the sides are the same. So we have a cube here, 2 centimeters, so that means every edge is 2 centimeters. So it's asking to find DG, and I've drawn in the right angle triangles. So let's do our Pythagoras' theorem. So we got dg squared is equal to dc squared plus cg squared. Okay, so let's evaluate dc squared. dc squared is just simply 2 squared. Cg is 2 squared as well. And we can square root all of this to find dg. Okay, so let's simplify this. We've got dg is equal to the square root of 8. We can simplify that. That is 4 times 2, root 4, root 2, which is 2 root 2. Okay, so we've established that the hypotenuse dg is 2 root 2. Let's use that now to find the diagonal FD. Okay, so let's use Pythagoras' theorem. Choose a different color. Let's do green. So we got df squared is equal to fg squared plus dg squared. Okay, so fg squared is just simply 2 squared plus dg squared, which is the square of this, and we can take the square root of both sides. Okay, so let's work this out. We've got 4 plus, well, if we look at this here, we can see that dg squared is just simply 8. And we can show that that's true by doing a quick calculation here. Squared with 2 root 2 times 2 root 2. Okay, so we have root of 12, which is the same as 4 times 3, which is 2 root 3. Okay, so maybe you can see a pattern here. These are referred to as surds, and surds are irrational numbers. So they are non-terminating, non-repeating decimals, which cannot be written as a fraction. So let's look at this cube again and see if we can find a pattern and eventually a formula for the diagonal FG. Okay, so let's now, instead of calling the side length 2 centimeters, let's call the side 8 centimeters. Okay, so we've got a squared plus a squared is equal to gd squared. So if we collect like terms, we got 2a squared is equal to GD. If we square root both sides, so we've got GD is equal to A root 2. Okay, so I'm just going to explain what I did. This rules of square roots. AB is the same as AB. So I've got the root of 2 multiplied by the root of A squared. The root of A squared is just simply A. And we can show that algebraically by doing A to the half, A squared to the half. In rules of indices, we multiply our powers. So half of 2 is 1. And also, we can say, well, the square root of 9 is just simply 3. 3 squared is 9. So squaring and square rooting are inverse operations of each other. So that's how I got this here. Okay, so let's use that to find the diagonal FD. Okay, so we've got A root 2 all squared plus A squared is equal to FD squared. Okay, so let's deal with A root 2 multiplied by A root 2. That's just going to be simply 2A squared, just using the same property that a square root squared is just the number below. So we get 2A squared plus A squared is equal to FD squared. Okay, so we can collect like terms. That gives 3A squared. And we can square root both sides. And we can simplify that to give A root 3. And that will give you the answer for any diagonal of a cube. So for instance, if I was to say, well, the side length of the cube is 7 centimeters, our diagonal FD would be 7 root 3. Okay, I hope this makes sense.